He joined Gammon India Limited of engineering projects and worked in various capacities. Sri Raizada as project director in projects undertaken by Mr. Gammon India Limited at nuclear power project at Kaita, wherein the construction was completed in record time. Sri Raizada was elected as Vice President of IRC in November 2011. May I now request the chairman and co-chairman to come to this dais. Thank you. As a token of love and appreciation at your gracious presence, may I call upon Mr. Ajay Burman from PWD to felicitate chairman and co-chairman. The Pulam Gamusa bouquet and a book named Garam Cha. Chai Garam, sorry. May I request Representative Sri R. Mesankar and Sri R. K. Jao Gopal to come to the dais. The presenter Sri R.K. Jayagopal is an active member in Indian Roads Congress in updating the standards in bridges and urban roads. He has his credit 25 years of experience in design, construction, investigation and testing of structures. His specialization is in bridges, load testing, bridges, various type of pile load testing, and he is trying to bring the better technologies for the benefit of citizens. Now, our chairman will conduct the session. Thank you.
Good morning, ladies and gentlemen. I hope you can hear me. At the end, you can hear me? Okay. Thank you. I must thank the Indian Road Congress for picking on me to chair the session, which I gladly agreed to. And we had two papers for this morning. I understand one of them is not going to be there because the gentleman hasn't come. But we are fortunate that we have at least one paper with us, and we will introduce the gentleman. He has already been introduced. To my left is my co-chair, Mr. Raizada. About him, you have just heard the introduction. And thank you. No, not so close. That's fine. That's fine. That's fine. I think since we're only one presenter, instead of giving the usual 20 to 25 minutes, we'll give him all the time he wants. How much time would you like that? Half an hour, 40 minutes, 45 minutes? Because it's a very interesting subject. His subject, the most interesting subject, is how to accelerate the construction of bridges, the techniques essentially dealing with precasting of the superstructures. I wonder whether you are also covering precasting of substructures? No. A little bit. We'll talk about that. So, since we have only one person to give us a talk on that, we'll perhaps request him to go ahead and tell us what you have to tell us, so we can then involve the others and go into a mode of discussion. Then they maybe ask a few questions. Go ahead, sir. No, I think your mic is not working. This presentation. These are the accelerated bridge construction techniques. Here, I am trying to create awareness, inform, educate, assist, and encourage the MRTH, IRC, PWDs, and urban local bodies to shift over to the conventional bridge construction to accelerate the bridge construction technology due to its enormous benefits. I repeat, I am only trying to create awareness, inform, educate, and assist, and encourage the departments so that the accelerated bridge construction technology is introduced in this country. Why do we need this accelerated bridge construction technique now? Look at the photograph. CNR Rao underpass, Bangalore. Mr. Rao was conferred the Bharat Ratna also a few months back. See the state of the underpass. Commenced in January 2010, yet to complete after 3 years, estimated cost 30 crores. Cost of fuel used in diversion of the traffic must have exceeded the total project cost itself due to the heavy diversion. Coming to one more project in the same Bangalore, that is Kadrihalli underpass, commenced in the March 2008, completed in August 2012. They are all actually of the order of tiny works. Estimated cost 28 crores. Period of construction 4.5 years. Converted to number of days, it may cross over to 1,200 or in that order. It is absolutely totally delayed construction, putting everybody into trouble and creating all environmental issues around the project site. Then one more project, these are all available right immediately what we see there. The Bangalore Airport Elevated Road commenced in September 2010. Expected date April-May 2013. Even till yesterday, yet to complete. Now coming to the progress of construction in Republic of China. The high-speed rail from Shanghai to Beijing, total length is 1,318 kilometers. 87% of length is elevated. 87% of the length is elevated, maybe around 1,147 kilometer length of bridge. Elevated in the sense of 1,150 kilometer length of the bridge. And construction period is 938 days. That is 1.41 kilometers per day is the progress. Here we take 4 years, 3 years to complete hardly half a kilometer, 1 kilometer underpasses or flyovers. Generally it's in India it's about 1 kilometer per year, the progress. We are behind Chinese
at least by 10 years in the conservative, actually it may be more also. In this context, we need to shift over to accelerated bridge construction technology on urgency basis to catch up with the rest of the world.
They are not able to provide these rights.
History
Then
of
why are we come over here?
accelerated bridge construction, it actually originated from Canada, probably due to the non-availability of the construction season,
अब तो उनको हुआ
and it traveled to USA and in many cities. I think they are trying to shift over permanently to the accelerated bridge construction due to its enormous advantages. Technique has reduced the cost in the society due to the faster way of construction.
কালি পাপুলার তোলো
The monetary cost of construction is measured in two ways.
একটু অগ্রদরে কাম
Actual cost of construction in rupees and monetary cost to the society by way of diversions, loss of productive time to citizens measured again in rupees. Actually now whatever the DPRs we prepare, we will have to include the monetary cost of the towards the society also into the projects. It is not merely the structural cost of the individual project. The intent of ABC is to reduce the construction time, thereby reducing the cost to the society. What is this accelerated bridge construction? This is that technology that uses innovative planning, innovative designs, innovative materials, and construction in a safe and cost-effective manner to reduce on-site construction time that occurs when construction of new bridges are replacing rehabilitation of old bridges. Where a conventional bridge takes months or years, a bridge utilizing accelerated bridge construction may be placed in weeks, days, or even few hours. In fact, whenever the ABC is adopted, we should never speak of months and years. We should speak only of either the weeks or hours. Conventional bridge construction versus accelerated bridge construction technology. The accelerated bridge construction technology improves the total project delivery time. It improves the site constructability. It improves the quality of the construction because most of the things are manufactured. And it improves the work zone safety for traveling as well as the construction personnel. This technology reduces traffic impacts, on-site construction time, and weather-related time delays. It will also minimize environmental impacts, which is absolutely going beyond control nowadays. Whenever the construction site, you cannot even enter. So much of dust surrounding 4 to 5 kilometers. You cannot even think of opening your offices or even the residential houses are affected. Their impact to the existing road alignment it minimizes. Utility relocation, it is nowadays taking huge time. That also will get minimized. Coming to the time matrix, when to apply this ABC, accelerated bridge construction, to gauge the effectiveness of ABC, two time matrices are used. One is the on-site construction time and the mobility impact time. When we add these two or subtract in one of the the ABC will get determined automatically. The accelerated bridge construction technology means, what it exactly means is planning shall be on the fast track. We cannot keep planning for 1 year, 2 years in a conventional way and then shift over to the ABC technology. No, when we start, think of that planning shall be on the accelerated mode. The design and communication shall be on the fast track. Construction shall be on the fast track. Quality control, testing on fast track. It cannot be 28 days. It shall be on hours or few days. All aspects related to the project shall be on the fast track, and whenever we enter the ABC or the accelerated bid construction site, we should be able to understand that the progress shall be in such a way that we should understand the speed with which it is being executed. The ABC technologies are: one is the superstructure, then the placement methods of the bridges, various elements of bridges, then rapid embankment construction, then of course the foundations. Coming to the superstructures, you have again bifurcated into two parts. One is prefabricated elements and one is prefabricated systems. The elements are individual structural members like girders, cross girders, slabs, and the prefabricated system is nothing but completely constructed span, completely manufactured span in a factory or a nearby place. That is the prefabricated system. Then we have the structural placement methods. When we manufacture such a heavy elements or the systems, you need to place them using some vehicles or cranes which need to take the loads enough. In that category, the structural placement methods, we have the self-propelled modular transporters. Then there is one more method, longitudinal launching, which normally we do it here. Then one more thing is which we have not seen in India actually here is the horizontal skidding or sliding. This is done using our PTFE bearings. You must have used many bearings of what PTFE. Similar PTFE material is used to horizontal skidding or sliding mechanism. Other heavy lifting equipments, of course, many types of cranes are there. In one of the prefabricated elements, see the stage one, shows various individual elements. And of course, all the joinery shall be joined using the high strength grouts. Stage 1 you can see. Stage 2 is already the pier cap or well cap laid and the piers are also completed to partial stage. Then see the stage 3 where the total bridge is completed. This is again one more precast integral abutments wherein we manufacture outside the site. This is one more abutment. This is actually the photograph of the pier and its cap, all prefabricated. And we have the precast decks using the pre-stressed beams, the bottom beams anyway manufactured, and we are doing it, however, not under the ABC technology. This shall be done absolutely at breakneck speed, then only it comes under the category of ABC. The slabs are all again precast. Then we have one more system wherein the steel girders are used, of course with all shear connectors. This is one of the site where individual independent pre-stressed slabs and steel girders are used. Here, see this steel girder, actually this is a part system. It is not a full system, it is not a full element also. That is about 1500 kg per square centimeter to 2250 kg per square centimeter. So that our 28-day strength parameters are totally cut down. We will have to execute the jobs to the extent when we need a structural member. Like in municipalities and all, we cast the slab, allow the slab to cure for 28 days and make the diversion, putting everybody into trouble. If you want to open a traffic, any culvert or whatever, in one day, design the mix for the next day. See that your concrete you design so that you allow the traffic whenever you want it, like the next day or 2 days, not 28 days as we are doing right now. Then we have the grouted splices, and these are all, you can see on the right side top photograph where the high strength grout is being pumped in a little bit different way in the connections. Then coming to the elements again, there are little bit different types of elements like a deck, bulb, T-beams where no slab is required. To design this element, girdle element only in such a way that the bulb is created at the bottom and the full slab to the extent is created on the top. So that whole of the superstructure is casted without a slab there. Similarly, there is one more method where double T beams. You can see there, every 2 beams, there is a slab cut is there. That is for the lifting easiness. And we have again inverted T beams. This is actually the photograph of the pre-stressed deck bulb system, where the slab is not required. Slab is already there in that element. And you see there again the jointry. Jointry is the same, that UHPC, ultra high performance concrete. Within few hours it will get set, required strength it gives, and that is the mechanism used in the pre-stress, in the precast. Coming to the system, what we have seen is the elements till now. Coming to the system, this is the full bridge is manufactured outside and it is towed to the bridge side. The whole superstructure is a type 1 where it is pulled, and the type 2 is using the slider. Even the type 2 where it is totally manufactured at site only, adjacent to the place where it is supposed to be shifted. Then we have the structural placement methods. The first one being the self-propelled modular transporter. In our country, this has been used only for shifting up some atomic power plant or some heavy machineries only. I think we have not used this much in the civil engineering sector at all. This is absolutely useful. Very much is in usage wherever the high-speed construction is made. What is this SPMT? Self-propelled modular transporter. It is a wonder vehicle for transportation of your elements or systems in ABC. It is large. It is a large multi-axle platform. Very large. It is computer operated. It can turn in 360 degrees. In whichever direction you program it, it will move. In addition, vertically it can lift also. It can lift also, it can lift the whole of the structure. Then it moves at walking speed. And each axle of the transporter moves independently. This is that one. SPMT carrying a full system to the site. This around 35 to 40 meter length superstructure. Because of adopting such technologies, China is able to complete projects in a higher speed. Here also, again bridges are moved on SPMTs. Extensively it is used. We have not used, I think we are not used here, even in the bottom also. Even the broken, removable bridges, which are to be replaced, can be replaced, can be removed effectively, efficiently using these SPMTs. After removal, it can be again, a new bridge can be put at that place. Then we have the horizontal skidding or sliding. It is such a fantastic technology where hardly two monostrand jacks are used to pull virtually about 5 to 600 ton superstructure into its place. Two monostrand jacks. Because it is slided on PTFE bearings or PTFE material where it is without much friction, it is pulled. You can see the right photograph there. The left one is casted, two slabs casted, two bridges ready to be pulled on so that they will be placed on the new location. This is the skidding mechanism. You can see the stage one where the white things are there. They are all PTFE. Simply they are simply placed. The stage 2 is pulling and the stage 3 is already in the position. Coming to the case study. See, we will have to adopt a technology where it is fully successful somewhere in the world. It is being practiced from several years and they got the benefits. The design, build, operate system in case study 1, which issues of notices at the February 7, preparation of the work. Actually, in this category ABC, the preparation of work takes little bit time, not at site, in the manufacturing plant. superstructure replacement was scheduled between June 1st and September 1. That is 3 months, and working only the weekends. That means 12 weekends. 12 weekends only, and finishing done after September 1st. All 7 bridges were taken up. One example, case study 1, step 1, Friday evening. That is a weekend. Transforming the road from 8 lanes to 4 lanes. Please see here, it is Friday evening. Again Friday evening or night, bridges are demolished. Saturday morning, demolition completed, ready to place prefab superstructure. This is 12 hours progress. Then again Saturday morning, transportation of prefabricated superstructure. Again Saturday morning only, they are placing the superstructure. Saturday afternoon, almost 24 hours. As I told you, the work in ABC shall be continuous, non-stop, till it is completed. Preparing the joints for closure pour. Closure pour is nothing but pouring the UHPC, ultra high performance concrete. That is on the Saturday afternoon. This is being on the left side, all the preparations are being made. This is yet Saturday afternoon or evening. On the right side, you can see the UHPC is being poured into its position. This is Sunday. Bridge has been paved with asphaltic material, and virtually it has taken only 48 hours. You must have seen here in our country, if we take up such project, maybe there are many exceptions, but regularly what we see is plentiful of inspections, plentiful of approvals, and completion of the project in hours we have not seen at all. Here, when we compare the conventional versus the accelerated bridge construction, the conventional construction has 5 stages, 4 years, worker safety issues, and concern of like for existing structure. By ABC technology, that is our accelerated technology, it has taken only 10 months to finish up all the 7 bridges what was taken up. Incidentally, this bridge, the first bridge replaced by accelerated bridge construction in Bangalore, in Wind Tunnel Road, we didn't know about 5 years back. We took up this project. It was completed in 7 days. We never knew that. We didn't know those days the ABC technology is there. We'll have to do faster job. Nothing. But we took it up because the bridge broke. Some Malaysian technology was there. A good contractor was there. 7 days. We did piling, cap, arches, and the whole period we took for including the casting of concrete, elements casting, all of the time, it took hardly about 21 days to complete it. Now this we didn't knew at all unless we checked up backwards, and we thought that yes, we also have done it, but we didn't do those days. Suppose if this technology is there, if the faster way of doing is there, planning to be faster, so we would have still made the whole project faster. Then we could have put our national flag also here on his arm, unlike the US flag in one of the movement of SPMTs. Also a part of the accelerated construction, one of the underpasses using the box push technology was completed in about 148 days, maybe a little bit comparatively slightly more, but however, here the testing was done in the accelerated mode, because testing was done every 2 hours for the elements for pushing into the position. Coming to the ABC contracting. ABC contracting shall also be on the fast track. You see the work order today, tomorrow work should start. Including the designs, incentives and disincentives clauses shall be a part of the contracting on ABC projects. Otherwise, we will go wrong somewhere. These I&D clauses are linked to the minutes. They are not linked to the, like today, nowadays what we do is days. LD class we operate day-wise. Now, what to do in India? The Ministry of Road Transport Highways need to establish a task force for development of strategic plan, implement and promote ABC practice. Because I have already shown you the photographs where in cities we take 3 years, 4 years to complete on tiny projects, whereas our neighborhood countries, their progress is kilometers per day. And in addition, the Indian Roads Congress need to create a new technical committee to develop standards, or the existing technical committee itself can be converted to develop necessary standards, guidelines, and you need not start from the zero. Already somebody has done some job outside, use that also. In case required, please visit the sites and necessary guidelines, key policies can be made for implementing this ABC by Indian Roads Congress. My recommendations: all regular bridge structures in urban areas, in specific the urban areas, including the flyovers and underpasses, shall be constructed using ABC technology only. Because every project has become held there in every city. All efforts shall be made to implement all other bridge projects in national highways and state highways by accelerated bridge construction technology to make the structures faster. Because nowadays we have the tendency to prolong each structure for unlimited time for various reasons. That's the reason the ABC technology will definitely put us in the right track.
Thank you very much, sir. It was a really interesting paper. I would like to ask some questions in order to get clarification. So after, I first perhaps would, maybe my co-chair, he might like to say a few words before we throw it over to the audience.
I want to thank IRC. This is the first time I am sitting this side. And that too with Dr. Rana. You can just imagine half an hour with Dr. Rana, so close. When I joined this company, Gaiman India, Dr. Rana was on the top position. And when I am at the superannuation age, he is also very young, and in the same position rather.
Thank you.
Thank you, Dr. Rana. So let us better to ask audience question for Dr. Jayagopal. Thank you.
All right, thanks. Go ahead, sir. Just introduce yourself. You don't have to get up. You don't have to get up. Mike.
Sir, you are known. No need to introduce us.
Yeah, I know, but for the sake of others. Where's the mic? Just 1 second. आप बैठे ही है ना? Where do you have to stand?
Hello.
मैं आ गया.
Hello.
Good.
I have done a large number of precast pre-stage bridges during last nearly 50 years. And even today, I am doing 10 bridges in Pune town. All are precast and launched in position. There are some problems which have recently come in. The precast girders will stand in position before lifting. And casually I wanted to see one of the precast girders. To my surprise, I found there are 21 cracks in that girder. Small cracks, not very big, and started investigating what is the concrete used and why the cracks have come. Then we got our surprises. The Pune Corporation has induced that minimum 540 kg of cement should be used in the concrete. This is horrible. People are not aware. 520 was given in the old code, but now the maximum limit of cement in concrete is 450 kg. And in Bombay, 100-story building is under construction, where the strength of concrete is 8 kg and the maximum cement is only 450 kg. It is possible to do that one. So that was one of the reasons why shrinkages have come. Then we found they have used this fly ash and so many other things over there. So there are a lot of problems about the concrete. Now then we decided what to do. I said the only method to accept the girder will be to test the girder for the design zone. That was reluctantly agreed by the contractor and others. And when we carried out this test and when we saw the laboratory and the mixing etc., lots of unnecessary things were being added in the concrete, such as fly ash looking like earth even, like that. They were being added. So therefore we have to remember that it is no use using unnecessarily more quantity of cement, thinking that if in your mithai you add lot of dry fruit, lot of green, it doesn't mean that it will have a taste. The taste and the quality must have a proportion. Now when this test was carried out, we found the recovery of deflection was 93%. That means it was a good thing to do. It's a good cement concrete. The second defect which we came across was that all the anchorages, where the concrete has come out. They were bad. The anchor blocks have either pushed in or come out like that. Now what was happening? I find in all these things, the concreting at the anchor blocks is not proper, and the contractors will go on complaining. There is a lot of steel. I have done 100 pieces concrete bridges and never come across this problem at the anchorage block. When you have to do the concreting at anchorage block, it is better, along with the vibrators, use a 16mm rod and dam the concrete, or use surface vibrators, which is absolutely essential.
Sir, that's very well, but could you limit yourself to questions?
Yeah, but question therefore is, what you are all saying here, therefore are these the problems faced by you? And what is to be done to avoid this one? Tell me about that.
Thank you.
That is exactly the thing I told, sir. You see, these are the problems. We take 3 years, we destroy the environment, we don't do the work in the meantime, we don't deliver the goods to the general public. Then one more is 4 years. Years together, we do the job. We don't have any technology. After all, the same cement, same aggregate, same fine aggregate. How some other country is doing? Can't we do ourselves? We had pioneers, even we have pioneers. That's exactly the thing. If something is good outside, we pull it out, we'll execute it. As I told you, why do we stuck to the 28 days? Where is the UNPC? UNPC is for 1 day, for hours. Yes, sir.
Sir, I am Alok Bhavik, consultant from Delhi. Firstly, I would like to congratulate you for this excellent topic which you have chosen, which is absolutely, very much required. Having said that, I have some observations also, which I would like to share, my experience of working in bridge construction. Firstly, I would like to differ with you, sir, when you said that the speed in India is 1 kilometer per year. I would like to correct you. We are doing metros, we are doing also several other projects where today the speed is...
Mike.
Where today we are achieving a speed of 5 kilometers per year, not 1 kilometer per year. So we are doing faster construction in India, very much there. But the term that you are using, accelerated bridge construction, which is a term commonly used outside India for...
Mike? No, Mike is okay, only you have to hold it closer to your...
Okay. What I am saying is that, the term which you have used, accelerated bridge construction, this term outside India is normally used not for fast track construction alone. Fast track construction we are also doing. But when you say accelerated bridge construction, it means that you do most of the work outside the actual site, working site, and you assemble it at site in terms of days or weeks, not even in terms of months. If that is the type of construction, normally that is called an accelerated bridge construction, which we do not do in India. My question to you is, do you think we are really geared to take up this kind of accelerated bridge construction? My feeling is that we are certainly not. Let me, sir, complete, then you can respond. There are 3 areas, where we have to work before we can even think of doing accelerated bridge construction in India. Number 1, our codes and standards. They are totally not geared to do accelerated bridge construction. In our codes, we are not talking about the joints, we are not talking about the element jointing. Our codes are mostly tuned to, normal casting situ construction and little bit of recasting. Number 2, even if the codes are there, you mentioned that, ministry should have a task force. Even if we come out with codes and standards, do you think that we will be able to straight away go for accelerated bridge construction? Certainly not. Because our construction people at site, our clients, our designers, our contractors are not geared, they are not tuned to this construction. It will take decades for us to come to that stage. Before that, it is much better that we take a slow pace of growth and do it. Thirdly, I would have much liked if you had also, included in your presentation something about the, accelerated bridge construction in terms of foundations, in terms of jack down method of well foundation, in terms of large diameter pipes where we can, put it in rivers where presently we are restricting ourselves to 1.5 meter, 1.8 meter diameter. So maybe, probably in your presentation, if you had included those things also, it would have been better. Thank you.
Right. Before I request you to give an answer, which is a very well asked question, my only point is, first of all, most of the bridges that he has been showing are in the States. Am I right, sir? Most of them, which he didn't say, but I could guess that. Then at least we have to be grateful to him for showing us that we, majority of us, did not know or had not seen. It's always easy for him to add to it in order to satisfy all of us, which he will one day, I'm sure he will. But meanwhile, at least he has thrown light on an area which is as good as dead here otherwise. To that extent, we congratulate him, and also you that you raised these questions. I'm grateful to you, Alok. Sir, you might go ahead.
Bhavik ji,
My only request is you'll have to shout a little louder because the people in the other hall are to be more
Yes, sir.
enthusiastic.
No problem, no problem. Moving regarding this ministry, I have already given the recommendations and all. Many times it depends on the client. See, as I mentioned here, it is not a technology where we will have to gear up so much. As I said, once accelerated, moment you enter, like the thinking of accelerated, let's go instantly. Say as here, you can see here, we didn't knew 5 years back, we didn't knew this bridge. This comes under the category of accelerated bridge construction. We didn't know at all. We simply started somehow. Because why we started? I tell you, because I think there was a brick arch bridge here. About 10 to 12 meters, it collapsed. The position was immediately it has to be restored. So there was some Malaysian, they call it Malaysian technology. Not actually Malaysian technology. It is the shuttering material was procured from Malaysia, and of course steam curing was done. So that was the method. It was already that we already did it. So in case if you want to tune, like see, you have done many bridges in that you know how to tune up our people. Only thing it may take a transition, a little bit transition, and definitely we can achieve.
I just want to add, sir, just one
Go ahead.
half a minute. I would like to say that it is unfair to completely depend on only the Ministry of Transport and Indian Road Congress to come out with standards. We have a huge, construction industry, and there are several professional institutions, and these professional institutions should come out with guidelines. If you talk of US, there are institutions like ASBI, American Segmental Bridge Institute, the PCI Canada. They have in fact all the standards that you see outside India. They are not developed by their respective Ministry of Transport or Indian Roads Congress, their Congress, but by these professional bodies. And I would urge that our professional bodies also should come out, and sort of take initiative.
No, but our works are executed by the MRTH and IRC specification. That's a problem.
No, he has a point. Alok has a point on this. You're right, but his point is very well taken. If I can come to the concluding part of what I want to talk about first, is the fact that in this country, unless it is blessed by IRC, nobody will build a bridge, which itself needs to be, that mindset, that frozen mindset has to be molded. One. Two, yes, you cited the PCI and the ASBI. Absolutely right. But here, unless our own people, I came back to the country after 40 years, I feel I belong here, somewhere at least. But the mindset has to be broken, has to be changed. Unless that happens, what you said will never ever happen here. They're not exposed to that kind of thinking. Even the accelerated bridge construction will never accelerate here under the conditions that prevail. But yes, they should. Totally in agreement. There's nothing wrong with what you said. Perfectly right.
Yeah, but I think it is.
Level supports. I have come across a bridge where in the wood there were 16 girders, small girders, no slabs. And these girders were kept in the bank. And I found, before launching them, 4 girders have developed cracks. And then I found that half the portion of girder was resting on ground and half on the overhand. The crack was at the center. As soon as we lifted and put them in position, the cracks closed.
Yeah, but that's bad construction technology. We can't blame technology for our inexperience or our not giving the right attention. That is purely a construction man's terrible mistake. He should be punished, he should be jailed. But he shouldn't blame the technology for that. Yes, it is happening, but I don't think the gentleman here has anything to do with that. Anyway, I have received some questions which I will go into, but any other persons, yes, go ahead. Introduce yourself, sir.
Thank you very much, sir. I am
Still
SSK
already
Principal
visible belakang.
Scientist, Visual Structures.
Still cameraman nasa kan.
I have a 5-year exposure to NHI projects.
Sorry, a little slowly if you don't mind. A little
Faster
slowly.
lagi.
Such a sweet voice, would like to hear all of it.
Tar camera
I
ase.
hope that my introduction part,
Yes, that we did.
ठीक है
That's
not
fine.
yes,
Yes.
I have an exposure of NHI projects of 5 years as General Manager Technical. I have a couple of observations. I think you have made a comparison. I agree with Mr. Bhomik. You see, seeing your presentation, I think more or less it's bridges or flyover projects, structure projects. Whereas in road projects, we come across a number of force majeure type of incidents. For example, land acquisition, utility shifting, environmental clearance. They also play a major role. But we have a number of successful case history of successful completion of BOT projects ahead of schedule. That is one observation. Now coming back to the second, quality control and testing on fast track. Now you mentioned the reference of ultra high performance concrete. Sir, you will agree with me. When we talk about our contingent scenario, the production of ultra high performance concrete itself is a very challenging task. You showed 2-3 slides wherein especially the jointing portion where the UHPC is coming into picture. Now the quality control aspect is mentioned that no need for 28 days. I agree with you. There have been established mathematical models. You can predict distance after 7 days or even now 3 days. But how you will react? Use of ultra high performance first, production in our country, and second, just compromising that quality control aspects, particularly when the jointing plays very important role whenever we consider the seismic consideration. Now the third one, I welcome your suggestion that Ministry of Road Transport and Highways
Please come to the point.
start
Please
about
come to the question because we have too many more questions here.
Thank you.
Right. Go ahead, sir. Go ahead.
Regarding the UHPC production and the cost. We didn't know earlier what is microconcrete about 7, 8, 10 years back. When somebody manufactured, we were depending actually on the construction chemical people like Bossrat and those people. And when there was some problem, when the structural rehabilitation of bridges or structures, building structures were undertaken, there was no mechanism to manufacture the microconcrete. They did it. There was no technology, there was no transfer, nothing. Now they wanted this fine material to be encased in the columns or to be encased or wherever they want in the girders. Even with the bridge girders, after adding the required reinforcement, they wanted to put the microconcrete. They did it. In the sense, they manufactured. They themselves. Why I am telling, we ourselves, we manufactured. Maybe we may be first people. Silicas, microsilicas, reactive silicas. The only thing we'll have to put our mind and do it. UHPC, it is just not coming from moon now. Here, maybe nowadays it is not like the olden days where import was banned or import we had a lot of problems. No, we can get any material, anything. So UHPC should not be any problem as far as even the manufacture wise, cost wise. And as far as the technology you are talking about the seismic or whatever joints, the research has already been done. That's the reason I told, let us not start from zero here. Somebody has done the job, take it further. Only adapt it to our country.
Two of the referred projects in India, have you used UHPC? Two projects, one underpass, any UHPC has been used in those projects?
I think in this underpass you are talking?
Two of the cases executed in Bangalore and North.
It was not, no, it was not required. It was not required. No, Bangalore project I showed photographs because of the delay. And as far as this photograph is concerned, UHPC is not used. Then this was a lateral temporary stressing was used.
Right. With your permission, sir, I have a few points to ask, and then I got a few questions I have received for you to look at. Some of them are somewhat similar to what I have asked, so that might reduce the number. But I will restrict myself straight away only to the point of question, not giving opinion. This ultra high performance company, we know in this country we know the HPC, the high performance company. What is the ultra about?
Ultra because it is 150.
150 what?
150 MPa, that is 1500 kg per square centimeter. Normally we go up to about 1000. About 1000 kg per square centimeter is the compressor strength.
Like 1500?
Yeah, M100.
The 28 day strength is 1500 kg per
Yeah.
centimeter. Ah, that's the ultra strength.
Ultra strength.
Okay. Right. If you're talking about bridges, and it's either precast or cast in situ, depending on, of course we can say the time. If it's precast, provided it is long enough to justify the setting up of the precasting factory. What is this cut-off point for the span length, I mean the length, overall length of the bridge, that if it is more than so and so, cast in situ is not advisable.
Exactly, sir.
Vice
That is
versa.
very important thing, sir. Actually, this technology we can go probably 30 to 40 meters. It cannot be beyond. It shall be the longer span bridges. Now this technology has this.
No, that's the longest you are talking of individual span.
Spans only.
No, I'm saying if the total length of the bridge is 300 meters versus 1500 meters. Now 1500 meters, if I go for precasting, I will be justified in setting up the precasting yard in the factory. But if it's only 300 meters, I may not want to go for precasting because the cost of that setup is much too high. According to you, your experience, what is the cut-off line for the total length of the bridge to be more than so and so to justify precasting?
No need, sir. We can change from the system to the elements. Instead of system, the whole bridge, we can shift over to the elements. If it is a small span, like the 3 span, it's already shown here 3 span. Shift over to the small elements where the girders are only casted, slab is casted.
Fine, fine. No, I was only saying that if a contractor is given the job of a 3-span bridge, he will perhaps, as far as I know this country now, I don't think he will bother to go for precasting. But if he is given a job which is about 700, 800 meters bridge, he will definitely think of that seriously. Because as I said, to set up the precasting shop is a huge factory. That will be justified only if there are hundreds, if not thousands of precast elements to be done. So any cut-off level on the cut-off on the overall length of the bridge, that if it's more than so and so, according to you, it should go for precast.
Yeah, if it's a small bridge, like the 3 spans go for these elements. If it is more spans, go for the systems. That's all.
That's what I want. Steam curing, any idea about the time cycle? Because this can have a big effect on the construction.
Definitely, sir. Unless steam curing is done, the fastness, the speed cannot touch it.
Sorry?
Unless steam curing is done, this ABC, this fast
That's right. I agree. I know. We all know. But what's the time cycle? Any idea?
That is not done.
As my friend Alok was asking, precast substructure, precast foundations, you have perhaps
No.
not much to say about it.
Just a first chapter of ABC.
No, I'm not blaming you. I'm only asking. You've done very well, don't worry. But when it comes to piles, if there are major structures like the one I'll be talking this evening, ceiling, 40 kilometers long bridge, there everything is breathtaking and your heart can lose a beat, miss a beat. If you make one syllable of a small mistake, because it's going to be repeated a million times. So there, whether to go for open foundation, caisson foundation, cast in situ, board pile, or driven cast in situ, or driven precast, and ultimately it had to be at different piles altogether. It had to be no driven pile, it had to be drilled pile. And for that, the equipment we had to do, we spotted around the whole world. We picked up an equipment because people in certain parts of the world are very speed conscious. We picked up an equipment which cost us $22 million, but we could chew through hard rock, 5-meter diameter, 1.5 meters depth in 1 hour. And we could produce 4.5 foundations per week, which is unheard of in caisson and open and other pile systems. So likewise, my friend, Alok, he was wondering whether you have some idea about that. Okay. Now, I'll give you some of these papers. I would rather leave it to you to read them because some of the points have been covered.
Question from Anand Jalgaonkar, bridge design engineer, plus current consultants. He's asked, what is the maximum load SMPT vehicle can carry? So that can be designed to any load because they are all modular. As far as the bridge is concerned, say around 35 to 40 meter length of superstructure of completely constructed. This must be somewhere around 600 to 800 tons. So this vehicle can carry, can multiply. It can carry any load, whatever you want it.
So what's the actual spacing in that case?
Axle space, I think, is about 1.5 meter.
No, because it can carry any amount of load is fine, but
No,
the bridge can't unless we reduce the spacing of the axle.
No, it's not spacing, sir. That actually, that length, what you see there, that they will add it up. Numbers, that's about 26 or about 28.
I know, I agree with you, but you can see the axles and the spacing.
Yeah.
The bigger the spacing, lesser the load that the bridge can,
Yeah.
because otherwise the bridge will not stay.
Yeah.
So that's perhaps partly his
Then, Sabit ACI, GM ICT. Have any cost comparison study has been made? That is actually the point I was interested to get from the audience. As for the cost consideration, I will tell you, cost consideration wise, this technology in ordinary bridge structures.
But no more questions after this because I know it's a very interesting topic and most of you would like to have more and more answers. But there has to be, every good thing has to come to an end. So after these, if at all you can go through all of them, we'll have to stop it.
Cost consideration wise, there will be 10 to 30% premium you will have to pay on the works. However, two things you will have to keep in mind. One is the contractor's premium. Normally, whatever it goes, many times it goes up to 30-40% in regular construction also. There is one aspect we will have to keep in mind: the cost to the society by way of diversion in the fuel cost, the citizenry's working cost and all. When we take all that, the structure cost of 10 to 30% can be easily digested. How this heavy superstructure can be transported given the state of the roads or bridges, especially in cities. You will have to check up. SPMTs cannot be operated in a regular city. Even if it cannot be able to take the load of the culvert cannot be able to take the load. You will have to design the whole length from manufacturing site to the placement has to be seen properly. See, you can divide it in such a way that either go for SPMT or a regular transport, like what we do in metros and all, for carrying the elements. Executive Engineer Mr. Satyanarayan, AP, Andhra Pradesh, Hyderabad. It is a very good topic to be introduced to the field engineers, designers with latest technology, to be propagated to the base level engineers as well as executing agencies. In fact, that is true. Many times our lowest engineer or just above lowest engineer will not know many of the basic aspects of the engineering itself, like the cements, concretes or designs. In fact, your suggestion is excellent. Pradeep, AEPWD West Bengal. What will be the axle load of self-propelled transport, whether the axle load within the safe limit of existing pavement or with the vehicle? Actually, your first question, IRC B8 committee, they recommended for oversized vehicles and overweight vehicles by about 20% or so. I don't know much about the subject of this particular thing came actually this SPMT. Somebody went and brought some approvals or something. There was circular issued. Again, as far as the internal thing of the B8 committee, they regretted a little bit that why did we allow it? Because somebody went and they passed some designs. I don't know much about it, but there was some pressure to allow certain type of vehicles on the beaches and roads. Of course, thing is, as far as the axle weight is concerned, that's about 5 ton or so. Axle weight in the sense here, there is no axle weight. There is 2 tire one side, 2 tire other side. It's a modular vehicle. It can rise up to the top. It can turn around. This is hydraulically driven. Like that, you can pair it, and you can buy it individually, independently also. You can pair it or make a full axle by using like this 1, 2, 3, 4 in one line. Then UHPC with final setting within 2 hours. What is the guidelines? So many things we don't have any guidelines. Structural rehabilitation. In fact, we have brought out some standards. In fact, all up to threadbare, nothing is there. And we'll have to use our sense and do it up. Further detailing is expected on the constants of substructure. Yes, substructure to the extent whatever you have seen there, only that much can be done. You cannot. You can cut also. You can cut and you can make not beyond that. Sir, yes, Tombe, Secretary PWD, Maharashtra. I think the time mentioned was time at site. Actually, some time is needed for design, planning, design approval, clearances, coordination. So actually, moment they think that this shall be at the accelerated bridge construction. That's all. The accelerated mind should start from there only for all the aspects like what you mentioned, like design, planning, approvals, clearances, work order issual, and after issue of work order, next day manufacture site, the consultant should be able to go there and start the job. That is the ABC. Many times reasons for delay are related to the land acquisition, utility shifting, funding, public resistance, or suggestions. Everything should be pakka, otherwise ABC will not work here. Good examples of works done very fast. one flyover in 5 months, one bridge in 38 days. Even with corrections methods, Lalbagh flyover demolished in 96 hours. Sir, it's yours. It's done by the conventional method. SPMT should be able to move on approaching. Actually, see here, SPMT wise, carrying capacity is not very much. Your WBM, old WBM itself should be able to take a little bit. WMM or GSPs, these people are used about a meter height on a regular subgrade. Just a meter. On that SPMT, they moved because nothing goes out because the spacing of the vehicles is in such a way that no settlement will occur. Yeah. That should be working. Definitely. Definitely. One Mr. Stosh Mishra, GM, MSRDC, Jabalpur. I would like to know, is there any tool developed to assess the monetary cost on the society? I don't think any tool is developed because every site is different. Every site is different, and we have actually, our DPRs, we have failed to put a proper DPR into position because cost to society has not been added up. In fact, a little bit work has already been done by the MSRDC. You people have done a nice job where the real estate cost which has been added to the DPR by some chartered accountant. There is some mandatory thing. Of course, even the Karnataka KRDC people also went there and they brought something. Now, that's a good thing, but there is no yardstick like that. And I would like to know where the ABC literature is available. Sir, where it's available? It's available everywhere. You take it. How do we achieve M150 225? Kindly, from tomorrow onwards, Mr. Ashutosh Mishra ji, kindly start making some mixes. I tell you, you will succeed in about a month. You will succeed to reach M150 and 225 in a month because that is my experience. Keep interest in exactly what you do. This is nothing but mixing up various ingredients to a common base wherein you will achieve the required strength. Like you use only the reactive silicas, you use the hyperplasticizers, you use the good cements in that sense only. Reduce the water cement ratio and you take the help of some construction chemical people. Sir. That's all, sir. 528. Maybe about 500 kg, sir. Not much. Otherwise, USPs will not work.
Oh, sorry, I'm so sorry. You should have thrown a stone at me. Anything of the order of 500 kg of cement per cubic meter of the output of the country is fraught with the dangers of heat of hydration cracking. And then the whole exercise is lost. It's not the same. So, you have any idea as to whether there were problems with this? Because then on top of that, along with that heat of hydration, you also go and do the steam curing. That adds fire to fuel.
No, this is only UHPC for the joints. This is not for our regular daily life.
Okay, all right. But no problems in
No
the,
problems. No problems.
at the joint,
At the
at
joint.
the cleavages between the old and the fresh concrete.
Yes, there will not be a problem.
I think we'll have to delay on that. We'd like to check in let us know.
Definitely.
Thank you. There is one last question, if you would care, because they already answered a lot. That's the end of it, sir.
Mr. P.S. Tyagi, retired C, UPPWD. Transportation of superstructure can be done, but what about the fixing bearings, particularly part PTFE?
What about the what?
Bearings, fixing bearings, and particularly the part PTFE, lifting of superstructure methodology. These are all. These are all very easy. Don't bother about it. Hardly you get. It is a play jump. Small jumps of say about 2 inches thick, and even a hand pump or a power pack that will take care of this.
This is normal. You don't. I mean, this is not a problem. This is a sewage.
Then the ABC limitation is for grade separators, underpass, but not for the river bridges. Everywhere.
The methodology of construction, you can call it what you like. Grade separator, bridge, flyover, doesn't matter what. Thank you, sir. Thank you very much, Mr. Jayagopal. Please come and have a seat. I am very grateful to Mr. Jayagopal for withstanding to try and attempt to answer all the points which obviously he hasn't done for all of them, but that's interesting to do.
only 10 minutes
And some of the very good questions, my friend Alok, and then Tata sir, and everybody else. I think the only thing that is left now for me to say is to thank him and thank you all. Thank you. Bye-bye.
পাৰ্টে এতিয়া আৰু বাকী বাজেটটো এতিয়া মই তাতে গৈ কিনেহে কি কৰিব পাৰিম কাৰণ মই ইয়ত আছোঁ
There are some.
মিটিঙত আছোঁ আৰু বাকী এইবিলাকৰ লাইট চাইটৰ কথা
Ladies and gentlemen, thanks for being with us, your concern and facility. Now I would like to request Mr. Opuru Barua, SE of PWD, to give the memento to Chairman, Co-Chairman and Alternate. This memento is a token of love and appreciation for your gracious presence. Ladies and gentlemen, this is the end of the session in Brahmaputra. For your information, other technical presentation will be held in Kaziranga and from 1:15 p.m. And I would like to inform you that lunch is being served at the field, so you kindly requested to proceed here. Thank you. Have a nice day.